Hello, everyone. My name is Gitika Gorthy, and today I am very, very honored to be interviewing a special space champion, Mr. Patel. Mr. Patel graduated with a Bachelor's of Science degree and a Master's of Engineering degree in Aerospace Engineering from the Illinois Institute of Technology in May 2020. Mr. Patel attained his schooling education from a multitude of cities in India. His educational experiences helped him to discover a love for physics and math, pushing him to pursue a career path that integrates these two fields. He was a board member of the American Society of Mechanical Engineering organization at Illinois Tech and served as a member of the American Society of Mechanical Engineering National Student Advisory Panel. He was awarded the prestigious Illinois NASA Space Grant in summer 2019 and Armour R&D Grant in spring 2020 for his graduate research, which was on inverted pendulum airfoil in a flow field, which won the best technical paper title at the Spring Armour R&D Expo in April. He was selected for the Space NASA Mission Concept Academy and supported the team as a lead engineer to propose a preliminary design review proposal for a mission to detect microbial life on the Mars surface, something that excites all of us.
Yeah.
He also volunteers as a NASA Lucy Space Ambassadors to educate the general public on NASA Lucy mission's goal and usefulness of asteroid research. Mr. Patel just joined the University of Illinois at Urbana-Champaign to pursue a Ph.D. in experimental fluids. His PhD research is going to be focused on understanding the translational flow behavior of different airfoil designs and developing a power optimized and wake optimized rotor used in helicopters. As displayed, Mr. Patel is heavily involved in various aspects of space and research, and I'm so excited to learn about his journey and what he does. Welcome, Mr. Patel. Thank you so much for taking some time out of your busy schedule to do this amazing interview.
Yeah, sure. Hi, nice to meet you, Gitika, and thanks for inviting me for this talk.
Yeah, I'm so excited to understand your journey of really how you got into the space industry. But before we get into that, I'd like to know more of your typical day. How does it run and what do you do?
Yeah, I mean, so basically, my day will just start with so like each morning when I wake up, I'll just the first few minutes of my day, I perform like a meditation, right, for a few minutes. And after that, I'll just check if there is something like, my emails and anything, right? And I'll just start doing my normal daily activity. I'll just make my tea, like have breakfast, get ready for, either meetings or classes. So right now I'm in a school, like PhD school. So I'm also taking classes while doing research. So I also have a class schedule. So I'll just check that schedule, be on track from, I would say, that runs until 4 or 5. I'll just have a lunch in between, and afternoon after 5, I'll just go for a walk on campus for 1.5 hours, maybe, or do exercise, right? Then I'll, have my dinner, and we'll then work for another 2 hours, and probably we'll go to bed. So that's my typical schedule for a day.
Yeah. I think it's really nice that you're able to incorporate a balanced lifestyle with,
Yeah.
research.
Yeah.
And I think that's really important, whether you're a college student and everything. Are you currently having virtual schooling or are you able to go in person?
So my yeah, I do have online classes, but my research work, that's experimental work. So I go in like a lab. So it's I mean, right now I don't go like daily basis, but on a few days of the week I still have to go there. So
Yeah. How has your research changed because of the pandemic? I mean, as a student and as a researcher, was there, anything that really changed for you?
Honestly, I don't think that it has changed much because, my current advisor, Dr. Philip Ansel, and I'm like very thankful to him and as well as the university that they didn't. So they just by the time when I came here in August, I think everything there was still lockdown at a few different places, but they still gave access to all the labs and all equipments for PhD students, so they can just go in the lab and perform research on maybe like when there is nobody around, or like maintaining social distancing and all those criterias, right? So I don't think that anything has changed since pandemic as compared to what normally I would have begun doing research.
That's
Yeah.
really good. I'm glad there wasn't too much of a difference. And so
Yeah.
that leads me to my next question is, could you explain your research on proposing a preliminary design review proposal for a mission to detect microbial life on Mars surface? Because I know that when I
Yeah.
read about it, I was excited.
Yeah, so we have this exciting news from yesterday, right? So
Yeah.
Perseverance rover was landed, I think, 1 or 2 days back. Yeah, so this was very similar to that, right? So I was part of this. I was selected for this NASA Aerospace Mission Concept Academy, right? So what they do is they will select like 500 students from all over US from different universities, right? And they will then divide them into a small team of, let's say, 10 to 12 students. So all those 500 students in a batch, they'll just divide them, and after that each team have to propose this proposal. So this proposal is basically doing like a basic level of calculation for a Mars like a mission, right? So what we do here is basically we do all those preliminary calculation that, these are the subsystems used for this missions. For example, we just sent a Perseverance rover, right? It has many different subsystems. So all those subsystems, they have particular weight, they have particular power requirement, right? And they also have a volume constraint because we are taking whole like instrument to like in a different planet, right? So we just keep all those constraints in our mind, and we have this objective. So it's basically this document just tells us that, keeping all these constraints, can we do our objective? So we just have to do all those like basic level of calculation, and that's what is all about this Mission Concept Academy.
Yeah,
Yeah,
that's yeah, very interesting. I think that's the best thing about programs like that where you get to work with like-minded individuals
yeah, yeah, yeah.
and yeah, and being able to, do certain missions or work on certain research is really exciting. So, how
Yeah.
did you get into experimental fluids for your PhD and like how did you get into the subject? Because I feel like it's very narrow.
Yeah, exactly. So that's actually a good question. That, like getting into PhD school also, it's basically like, it's like a bottlenecking your interest into like one specific thing, right? So how, so aerospace has like many different domains, right? It has a controls and systems, it has a fluid mechanics, and it has a propulsion. Then it's like people who are interested in there are many different kind of things, right? In the space industry, in the space research, and there are many different things. So I know that, based on my interest in my undergrad school, I was interested in two domains. The first was fluid mechanics and control system. So when I was in my junior year, I had this wonderful opportunity to work with one of the professor, Dr. Sibani Dattawarua, in her space weather lab. And I worked in her lab for like 6 to 8 months, where I was tasked to calculate the error in the GPS signal, and that error was basically due to the dispersion which occurs in the ionosphere layer, right? So I worked in that domain, and now I knew that, what my future will look like if I just go on with this research, right? And I also wanted to explore the other wheel of my interest, which was the fluid mechanics, right? So then I had this another opportunity to work with one another professor, Dr. Scott Dawson, and we work on this project, the inverted pendulum airfoil. So it is basically, if you have a stick and you try to, have you heard like children's like balancing them?
Yeah, yeah.
Yeah, it's the same thing like that. So we have basically an aerofoil, and you have to like balance that aerofoil in like all kind of disturbance condition. So imagine that, you have a rocket, and it has to like take off, right? So when it is taking off, it has to maintain its vertical orientation in spite of having like disturbances from airflow and all those things. So what they do is there is an engine at the rear end, right? So basically the engine neglects all the disturbance effect, and it just maintains its vertical orientation for like few minutes until it goes away from the Earth atmosphere, right? So it was like that we have this model airfoil, and the air is flowing from the top, and we design a controller which can balance this in the many disturbance condition. So I was really interested in that project. And so this was also, so once I have identified a specific domain, which was fluid mechanics, right? So then also research is performed in three different ways. Each domain in aerospace, it is either performed in computational way, it is either performed in experimental way, or it is performed in a theoretical way, right? So in the theoretical way, it's like we just do like derive the formulas and we do like all the calculations, right? So that's theoretical research. The computational research is basically you run simulation, right? So that's what I was doing. So my work at my graduate college was just computational research. And the experimental research is basically you make something physical model, right? You make a physical model and you test them, right? So that's what another thing which I was like interested in. Okay, now I'm in a fluid mechanics. What I want to do? Do I want to do this computational, experimental, or theoretical? Then I was like, okay, I'm a more of a I want to do a physical work. I want to work in a lab, and so yeah. So that's how I was like, there are many different projects that you just have to see that what kind of projects are available and what kind of professors are working, right? So yeah, and that's how I decided to like do experimental fluids for my PhD program. Yeah.
Yeah. Were you always, when you wanted to get into physics in general or like experimental fluids, was there a childhood, class or maybe like, in high school, something that intrigued your interest in, space?
You mean aerospace, like
Yeah.
my domain, which I
Yeah.
choose?
Hmm.
Yeah, I mean, so it's basically, I think my interest was built after my 11th and 12th standard, right? So I mean, in my physics class, I was like really good at math and physics. It was my key area, right? And in physics also, I used to learn about this. There are few conferences which I attended, and there are many different, like space talks, like talk from like previous alumni or like space people, like space industry personal giving talk. And I was very interested in those things. And I was like, I want to do something similar, right? I want to be like in dread tech. I don't want to be like them, right? But I want to be in that direction. So I just knew like a general direction that where I am going, right? And like as I move forward, as I moved along my journey, my path became like very specific to one
Yeah.
particular thing, and that's how I move along. Yeah.
Yeah, as you keep, you will always start broad. We're like, oh, we like science, and then in
Yeah.
science there's subjects and yeah, so forth. It's always continuously learning and from projects. And obviously from your background, I can see you've been part of many projects and
Yeah.
many research opportunities.
Mhm.
So out of all of them, if you had to pick one, what is the most exciting project you've worked on?
I would say my current project, the current project which I'm working on experimental fluids at my current level, it's a very exciting project. So, I had a talk with my advisor before I took admission to the school, right? And my advisor, he explained me the entire project. So what we are going to do? So he was like, okay, so we are going to develop, we are going to like optimize the rotors, so there are rotor blades in helicopters, right? So how can we better optimize it? And what's why there is a need to optimize, right? So if we make it better optimized, we can hopefully reduce the power consumed, the whatever power it currently requires to like rotate the helicopter blades for a particular thrust coefficient. We can reduce the power required, and which is power is basically our fuel, right? So that's what we can translate, that we can, it's like a practical problem. And another thing is you can also try like different ways to like mitigate the noise. So the noise in the helicopter blade, it is generated due to the tip vortices formation, right? So we are also trying to like mitigate the tip vortices formation at the at the helicopter blades, and it basically improves its efficiency, right? So first we do run like computational simulations in computer, and currently we have developed this code, and our code is ready. And like once you put all the parameters that, hey, I want to lift or develop a helicopter which can lift like let's say 10 ton of weight, right? And basically it translates to a specific thrust coefficient value, and we input that in my code. And once you click run, it gives like output of the geometry of the entire blade. And once we have the blade geometry, we basically 3D print them, and we will 3D print them, and we do a validation that, hey, whatever we thought of doing it, are we really doing it, right? So we just do this validation comparison of our computational research and experimental work. And yes, so it's a really exciting project, and I really like it working here. So yeah.
Yeah, it sounds like an amazing and interesting research project. And I
Yeah.
know there's many, college students or even, young high school students and even further beyond where they're always looking for ways to earn grants to, make their ideas come to life. And
Yeah.
you were awarded a very prestigious Illinois NASA Space Grant and Armour R&D Grant for your graduate research. So
Mhm.
how are you able to, as a college student and a researcher, able to get these grants? Like, did you apply for them? And, what was the process behind it?
Yeah, so that's a good question. Yeah. So the thing is, so this my graduate research project, which I work on, the inverted pendulum one, which I mentioned, right? So I carried out that project on for, I would say, almost one and a half year, right? Almost throughout my uh, senior year of bachelor's, like senior year and my first year of my graduate school, right? So so when the time, so basically how I came to know, it's from the department, that the department sent out an email to all the students that, hey, we have this wonderful opportunity, like grant from NASA, and if you want to apply for it, you're feel free to do so, right? So by the time when I was going to apply for this space grant, I was already working on that particular project for 6 months, so I already have like a really good understanding of what I'm going to do. So my proposal was comparatively very strong, right? And so yeah, we basically propose a project to our university, and our project was hopefully approved, and we are just awarded this grant. Yeah.
How are you able to find these opportunities? I feel like, when I talk with many individuals, I think the number one issue in any career is, opportunity and awareness of knowledge.
Yeah.
So where do you, where are you able to find your knowledge and get, understand that these opportunities are out there?
Yeah, so it's basically, this opportunity, like in terms of, like, are you talking about space grant or like a job opportunity or
Grants or any
grant?
education opportunity
Yeah.
in general, I guess.
Yeah, so I think the best way to know, as a, if you're a student working in your, let's say, undergrad or grad education, basically, the emails, your department send out the like particular emails that, hey, like, if any grants is awarded to the school, or if they have some available opportunity. So just, just stay tuned with your email communication with your school. That's the first place, or maybe you can also talk to your advisor, like whoever professor you are working with, because they are at much higher, like, in a hierarchy or model, they know like a better view of what students grants they have and those things, so you can talk to them, so those are the ways I would say to know more about the grant when you are a student, right? So that's like a student. But once you are in a professional career, that once you are maybe a professor, or after you're doing your PhD or something, then I think there are many different ways, like knowing from conferences, or a direct announcements from like space entities, or NSF and like NASA, and they used to announce like call for proposals, so those are the thing for like later stage. But at the student stage, just stay connected with your university and it should be enough. Yeah.
Yeah, I think it's always important. Like as students, sometimes we get caught up with, 20, 30 emails and we don't actually read
Yeah,
them. I think sometimes just taking a few minutes out of your day to look through, because you never know
exactly.
when there's an opportunity or two.
Yeah, exactly. That's a, like paying attention to like minor details. That's what, like this opportunity was just a one line in my, entire list of email, which I was just ignore or something like that. So
Yeah.
yeah, so you should like paying attention to those things will really helpful. Yeah.
Yeah, yeah. When I read about your profile, accidentally when I was reaching out and looking at your LinkedIn profile, I was like so intrigued by your research project and your story. And so that kind of brings me to, I really want to understand more how you got into the space industry. So you said that you went to many schools in Gujarat, India, in your earlier education days.
Yeah.
So how did those educational experiences help you?
Yeah, I mean that's also a good question, and I think so. The thing is, the more places. So I had this. I mean, I honestly what attended 4 or 5 different schools, going from my first grade to 12th grade. Yeah, so I think the way I would put it, that the more places you go, the way they help me is that you get to know more people, right? You get to know more about their culture, right? And each specific culture has something good, like like if you meet a specific person from one particular state to another state, you learn about, you see like many different things, right? So the way they talk, the way they walk, everything is, the day they perform the daily activity, the day they study, or the way they play some game, so everything is different, right? And you like I just enjoy like learning more about their culture. So let me give an example. That, for example, when I was in my, let's say, first or second grade, I just went to one school which was in my town, right? So when I went to in that school, I had friends from entire town, right? One town.
Yeah.
So when I went to another school in my fourth or fifth grade, that school had many friends. I made friends from like different cities, like 2 3 cities like nearby.
Mhm.
After that, in my 10th grade, when I went to a different school, I had friends from like different districts in
Wow.
Gujarat, right?
Mhm.
And after my high school, in my first and second year of college, right, of when I went to this SRM University, where I studied my aerospace engineering, there I had friends from like different states, right? And basically at the end, when I came to US, then I had friends from like different countries, right?
Yeah.
So
Yeah.
it's basically like you build your network, you get to know more about different people, and it really helps you with knowing like a entire picture. Yeah.
Yeah. Yeah, I think definitely networking is like a huge skill, whether it be, as a young student or, as a professional in a career. I think being able to, use your connections, work with others, and, meet like-minded individuals is
Exactly.
always very important in your career.
Yeah. So if you are basically among the one, with, as you mentioned, like if you just stay with your like-minded people, it helps you, like, you enjoy your life. That's, perform daily activity, and you also like get your work done, right? So so it's very exciting to be among that group.
Yeah, 100%. So was it very difficult from you coming from a different country? Obviously, you said you went to different schools, so you're probably used to new cultures and new experiences. But was
Yeah.
it difficult, transitioning from a different country to get into the space industry, coming from India to America?
Yeah, so I mean, in terms of when I came here, so I just came here for to study, right? So continue my education, right? So at my college level, I don't see there is a much difference. Like when you are like trying to learn something, of course there is your courses which you learn in India and basically what you learn here. They're going to differ by a bit, right? But if we talk about space industry, then in terms of like future job opportunities, and I think this is one thing important, that there is a big gap between, because the space tech giant industries in US, the companies like NASA, Lockheed Martin and Northrop Grumman, they have like SpaceX even, so they have this ITAR requirement. They have this ITAR requirement, so they don't, hire international students directly, right? So maybe, but there are many different ways around it. So maybe you can work with their subcontractor. So for example, my current PhD project, it's a US Army grant, right? So the Army is giving money to my school, and school is basically hiring students like me who can work on that. So so it's basically you can reroute your, uh, you know, uh, reroute your the opportunity. And those, like, there are also many different, like, I would say, the startups, and there are many different like small scale company where you get to uh explore your passion in a great deal. Like, if you're working in a small industry, it's, I think, really helpful as compared to if you are working in a big industry, right? Because I think, according to me, I'm not sure, okay, but each person have a different view, but I think in a big company what really happens is, like, you are just there to like press a particular button, so just press this, right? And just press this at 7 or 6, something like that, right? But if you are in a small scale industry, then you do many different things, and you learn a lot, right? So that's my take in terms of the different things I see between different countries. Yeah.
Yeah, I definitely believe that the space industry is becoming so much bigger. I feel like it's no longer just government space agencies like NASA or ISRO. It's, it's something beyond, it's bigger. A lot of smaller companies, a lot of startups, a lot of space consulting companies are being created in order to create more space jobs, whether it be for, people who are in this country, outside, international workers, whatever it may be. I feel like it's so much more diverse and inclusive, which is amazing. And, you just told me that you were an international student, which is
Yeah.
true. So have you had any obstacles? I mean, whether it be just a student in the aerospace industry or as an international student trying to pursue a career here?
Obstacle in what sense? I mean, it's
Like, were there moments where you had trouble where you couldn't, apply to a certain program, or, or you felt that I can't pursue this specific degree or something because I don't have this experience, or, something like that?
oh, okay. Yeah, I mean, so one obstacle which I think I face is, so when I came here, I was having a bit like communication barrier, So like so I just spent my entire like previous, like I just came here in 2017, right? So before that, my mother tongue is different, right? So when I just came here for my junior year, so I was like barely able to understand, the accent is different, like
Yeah.
I was in English, like my all my high school I was an English medium school, but the accent is different. So the way the professor talk, it's different. So the first semester was like I was really struggling that what my professors are trying to say, and like uh so when I was learning, so it was but as the time passed, I got to use to that atmosphere, and now I mean I don't think I have a problem. So that's one of the obstacle I faced. Other than that, I don't think I saw much changes here. Yeah.
Yeah, your English is perfect. I did not know that you came here in 2017. You're perfect. You have perfectly normal English. I didn't know that at all. So that's really nice that now you're able to overcome that language barrier. I feel like when you come from different countries, like my parents
Yeah.
were also, first generation immigrants here. So, that language barrier is always hard at first, but I think that's something that totally we can overcome because space has
Yeah.
no boundaries at all.
Yeah.
So, did you always imagine yourself in the position you are in today, or did you kind of have some twists and turns? Like, I know you said you always were great math and physics students, so you probably always had this path, but were
Yeah.
there any moments of twists?
Yeah, sure. So before I go on to that, I just recall a really good point of our previous thing, right? So how I actually overcome that my language barrier, and so I think one thing. So I just want to like mention that. So so when I was facing this language barrier, so what I really did is, whenever I'm in a meeting or something, I would just ask my professor or somebody else that, hey, can I just record the conversation? So I would just basically, record, like, if or maybe there are recorded classes as well, right? So, so I'll just go through that like once, twice, until I get it, So,
Yeah.
so this thing, so that's a very simple thing, which I use to like overcome that. And regarding the second question that, uh, if I had many twist or turn in my career, right?
Hmm.
So I think I did have a twist in my uh like a small twist in my career, but I actually it just put me in a better place. So let me tell you that. So when I just started the school, my undergraduate education, like in bachelor's degree, I just thought that after getting my bachelor's degree, I will just work in industry and I don't have to like go for master's or PhD or something else, right? But I think once I just started the school and I came here, I was like really interested in this topics and the research work which I was doing it. So that just kept me like fueling my interest, and I was like, okay, I don't want to stop at now in
Yeah.
between, So then that's how I, completed my bachelor's degree. I joined like graduate school, completed my master's degree, and then I was like, hey, do I want to like work for 1 or 2 years? I was like, no, I don't want to stop in between. I'll just work. I'll just complete like my entire education career in one go, and after that, I'll jump in the work industry. So that's what I mean. A small twist which I have seen in like what I anticipated being at some place and where I'm doing it. Yeah. So
Yeah, I know there's students who I meet who take gap years or they work
yeah.
while they're studying, and there's so many different paths, honestly. So I'm glad that you were able to do it for the better and, pursue more interesting research that you like. And it's honestly more educating before you go into the industry, so you feel more comfortable.
Yeah, and I think another thing is like if you, it's really I wouldn't like undermine the the work experience which you get from internships and
Mhm.
the other things, right? So, but so according to me, so according to me, like for example, if I just take a gap year or something like that, if I take a break, that actually that your daily activity changes basically, right? Your daily activity changes, so your that changes the way you look at things, or maybe the way you study. That's what I would put it, right? So I think once you are in the industry, then it's a bit difficult to get back into the school and like go on at the same pace that you were working on before. So I think that there is a difference. So that's what I just keep in mind. Yeah.
Yeah, I definitely think, I know students who never take a break with their education, but during the summer they, go into internships or, some immersive experience or hands-on where they can actually work in the industry, but not stop that continuous flow of learning.
Yeah.
And
Yeah.
so yeah, and so now that we've kind of got an understanding of your research and your journey, which honestly, I'm sure, many students, many first generation to here, many foreign students who come in, they're faced similar situations, especially, graduate students when they're doing research, applying for grants. All that advice you gave is so helpful. So to kind of wrap up the interview, I really wanted to ask you this one question, which is, what advice do you have for young people regarding their pursuit of a passion in the STEM field or the space industry, something that you wish you knew when you were young?
Yeah, that's a good question. So yeah, I would say two things, right? So the first thing which I would say to young people, or maybe the high school students, right? Or maybe like any junior or maybe bachelor's or graduate student, that you should never stop doing something. So for example, if you decide something, like, hey, let's say I want to do something, let's say I want to complete task A, right? So make sure you think about that task 100 times, before that. Before doing that task, make sure you decide all ifs and buts and because, and you answer everything in your mind, right? But after thinking about that task for 100 times, and once you have started that thing, then no matter what, if there are 100, don't stop it. If your 100 reason not to do it, once you are into it, you should not stop it. You just keep going ahead, so that's my strategy that I actually follow, that once, before doing something, I'll think 100 times, but once I've started, I'll never stop. No matter what, I would never give up. That's just me. And another thing that I wish I knew from when I was in my high school days is, and I think it's really important that, at the time, I always used to fear failure. That, hey, if I just fail this particular exam, or if I just fail this particular thing, then I'll be left with nothing, right? And I think so that's the common fear, I think, which actually I had in my high school days. But what I have learned over this past years is, failure will never stop you from doing anything, right? Failure will never stop you from doing anything. It will just reroute you and will put you at some better place. So that's what I have learned throughout, and that's the advice which I will give to all the young minds out there. Yeah.
I think that's amazing advice. I think definitely once you start something, the idea of always completing it, no matter the difficulties, because you
Yeah.
never know the fruitful results at the end. It's just
Yeah.
a matter of pushing through it. And then definitely your second advice, which was, don't feel fear failure. I mean, I'm a high school student right now, and I know a lot of my friends and I sometimes we have this important midterm or exam, and we're like,
Mm.
oh, if we fail this, we get a bad grade, which impacts our GPA, which means we don't get into a college, which means we don't have a career. So there's like, I mean, that's how we used to think. Like, it's like a chain effect because of this
Yeah.
one, like, midterm. Like, it doesn't actually, like, the midterm is not going to stop you from a career. I think it's just like this fear that develops in student minds that, makes you worried. So I think always trying to stay confident and like, um, just overcome those fears and not actually make every small thing like the end of your life is it's an important
Yeah.
concept to like ingrain.
Yeah, exactly. And I think that's a common thing which all, I think, high school students will have. And I think, I'll just advise them that, it's not a thing. You know, I mean, at one point in your life, you will reach at a stage and you will think that whatever I did at one particular time, it really doesn't matter. So that particular
Yeah.
midterm is not going to matter after 1 or 2 years of your career, but the way, the attitude you build. So the failing of the midterm, if you fail a midterm, it's not going to affect you. But after failing that midterm, and if you just decide, hey, I failed, and if I failed and I didn't get up, that's going to affect you. So the reaction, your reaction to that failure, that's going to affect you. And because you will have that thing in your mind for entire career, that hey, if I'm not able to do something, I'll just change. No, it's not like that. Just stay with them, get through that situation, and just stay with that. So, yeah.
I think that mindset and that positive attitude and like that right mindset to grow from it is really important. I think like no matter even if we fail something, like in elementary school, I remember like I had to get like all perfect grades. In middle school, I was like all perfect grades. And now I'm in high school and I'm like, why was I so stressed out in middle school and elementary school when, it's really not that big of a deal in the long run. And probably even high school. Like now I'm in high school, so I probably think it's a big deal. But if I look back at it, maybe it's not. So I think always having that perspective and whatever failures we have, trying to overcome them is really important. So thank you so much for this amazing advice, Mr. Patel. I really, enjoyed listening to your experiences and your advice, as well as your amazing research that you're conducting. And I wish you good luck in all your future endeavors.
Yeah, exactly. And also, I would like to mention one another thing is that, right now, me and three of my colleagues. So one of them is, he's a pilot in Canada. There's one of my other friend who's a controls engineer he's in one of the Chicago industry there. And there's also one of my friend who just, I think he's going to graduate with a master's degree from Illinois Tech. So what we are doing currently is that, we are taking approximately, we are selecting a like high school student who wants to be in the space industry, who wants to be either like aerospace engineer, aeronautical engineer, or who wants to be in the pilot, like who wants to become pilot, right? So what we do is, so we have planned this academy for like 3 months, and like we just conduct like online classes, it's a 1 hour session every week. And in that, we just explore their curiosity, that hey, that if they have some suggestion, if they have any questions or anything about like that, if they have any questions or something like that, we'll just try to help them. We'll just give them advice, and it's absolutely free of cost. And the reason we are doing it is I have seen many people that, once they get into a particular degree program, the dropout rate that, there are many students who just change their major. So, if so something like that happens, then it just wastes their time and, their entire, what you can say, resources and all those things, right? So basically we are just selecting the students and we are giving them like a, trailer of their entire space career, that hey, if you are in this industry, we'll actually teach them physics, that how does an aeroplane fly? How does the lift and drag, what are the different kind of forces? What are the different control surfaces on an aircraft? Because I don't think that in high school, the students are just taught at this particular detail.
Yeah, no.
So we just tell them this, and we just show them that hey, what's the space industry is all about, where we stand, where we stand in like here in like US, what's the status in different countries, where the industry is like moving ahead in future, and all those things. I think this advice helps them to get like a transparent picture of their career. And if after doing this, if they're really interested, then they will just get into school without any problem. Yeah. So that's the thing we are doing, and I'm very thankful to all my colleagues, others, then Kaumil and Pratik for helping me conducting this academy.
Yeah, I want to just first of all say thank you for doing this amazing initiative. I feel like high school students don't have opportunities to explore careers, especially like general specific careers in the space industry,
Yeah.
because not many people are aware of it. So having, students like yourself and, spreading your love and also like showing high school students this is what we do. And if you're even 1% interested, you should come to our, webinar, and
Yeah.
it's free of cost, and you're doing this for the betterment, and, you're providing you've already been through the path and you're
Yeah,
providing that easier path to other students. So thank you so
exactly.
much for that. And I'll definitely put in the description like your contact information and hopefully how to register for the webinar. I'm sure many high school students and even maybe even younger students who
Yeah,
really want to get into the space industry would
yeah.
love to talk to you.
Yeah, exactly. And the drones which actually the students of undergraduate education, like bachelor's degree make it. In our academy, we are teaching students how to make drones, right? So the students of ninth grade, I mean, the first year of their high school, those students. So right now we have this academy for currently we have 20 students, right? We are just selecting a small academy, so they are making these drones. So we just tell them about what parts to get, and we provide them all the resources and yeah, so they are just learning these new things, and it's also very exciting for us, so yeah.
Yeah, you learn better when you teach others, regardless of whatever skill set it is. So I just want to thank you for doing such an amazing initiative. I wasn't aware of it, so thank you for sharing that with us and taking some time to share your story. It was really inspirational and motivating that regardless of where you come from or your background, you can be a part of space. So thank you.
Yeah, no problem. Thank you so much for your invitation. Yeah.
Thank you.